Crewton Ramone's House of Math.com for more. Alright, Crewton Ramone's House of Math, fooling around. Oh, and how's the weather over there? I understand that it got a little chilly.
On Tuesday, there's going to be no school.
Because there's so much snow. That's tomorrow, is Tuesday.
Yeah, and on Monday, there's going to be no school because it's going to be negative, like, 40.
Negative 40?
Yes.
That's crazy. That's like on a different planet crazy.
It is.
Man, you gotta shelter your cars and all kind of stuff because that'll crack your engine blocks.
That's what happened on Uranus.
Yeah, I know. That's what I mean. That's like crazy cold weather. Okay. Wow. All right. We're doing equivalent. Oops. We're doing equivalent fractions. How old are you again?
7.
7. So this would be super crackers for you. This will be easy for you. All right. So let's start off with easy ones. Like, what's 1/2? What's the same as 1/2? 2 what?
2/4.
2/4. What if I got all crazy and I said this was 16? What would this have to be down here for it still to be 1/2?
16, 32.
32, right? Because it's just twice as much, right? Easy.
Yeah.
So the relationship is the same, right? And okay, and we got to cover all the different parts. What is this part called again? Do you remember?
The denominator, or the denominator?
The numerator.
Oh, the numerator.
You're very close. No, you're close. You're good. And the other part's called what?
The denominator.
The denominator, right? The nom of it and the numerator. So the numerator tells you how many. The denominator tells what kind. So this is 16ths of the 32nds kind, right? And you remember what this line's called, just for fun?
The equals?
Well, that's the equal sign, but this line. If I have it like this, it has 2 names. It's a vernaculum or a solidus.
What?
Yeah, see, you don't need to know that, and it doesn't matter. But anyway, we're humans. We name everything. Everything has a name. Vernaculum, solidus. Right?
Okay.
Or the other way around.
Vernaculum?
Yes, vernaculum.
Vernaculum.
And solidus. This is a solidus, this is a vernaculum. Alright.
Oh.
Let's fool around with some other equivalent fractions, like common ones. Like, alright, this is 1/4. So this would be 2 what? Let me get my happy blocks out and we'll talk about it.
Is it either 6 or 8?
Why would you say 6? You can't be wrong. You know with me you're never wrong. I'm just asking you, why would you say 6?
Because it's +2.
Oh, I see. You were thinking +2. Okay, well, we're talking about doubling here. So get out your blocks, and I want 1 to 4. Do you have these kind of blocks? Do you have these kind?
Yeah.
All right, so grab those. And make yours look.
Grabbing
Yep,
those.
make grabbing them.
Go.
And you got a pencil and paper handy?
Yeah.
All right. Get all this stuff out of the way. Alrighty, we're happy now. What is that? Oh, that's the eraser. Okay, so can you see I have 1 to 4 is the same thing as 2 to how much?
To 8.
8. Alright, so we're going to write that down. So 1/4 and 2 8s are the same thing. So can you see that this is we just multiplied 2 by 2? Right?
Yeah.
So when I do my thing here, I moved over by 2, moved over by 2, so of course that makes, right? Now, here's another question. Can I move over the top without moving over the bottom?
What? I couldn't hear you.
I said, can I move over the top without moving over the bottom?
Yes.
Try again. How could I do that? How can I move the top without...
No.
Alright, so let's try, now what? What if it's 3? Now what?
You can still?
Yes, I moved it over. So I'm saying 3, we're just doing equivalent fractions. So if it's 3 on top, what's it got to be on the bottom for it to be the same thing as 1 to 4?
Oh.
12. There you go. Write this down. Write it down.
Okay.
You are absolutely correct. In fact, you know what? I'm going to move over here. 1 to 4 is the same thing as 2 to 8 is the same thing as 3 to 12 is the same thing as 4 to 16, right?
Yeah.
What's the next one going to be? 5 to what?
5 to 21.
How'd you get 21?
Oh, sorry, 5 to 20.
There you go. Alright, so let's get nuts. What if it was 6? What does the bottom have to be?
Wait, I'm first putting all that down.
Okay.
24.
I like it. And see, his speed of writing and your ability to work a pencil does not reflect your understanding of the concepts. Simple as that. Just because you can't write fast doesn't mean you don't know what's going on, right?
Yeah.
Alright, what if I got nuts over here and I said that this was 36 down here? What would the top have to be for it to be 1/4?
Down there. Wait, 36 down there?
Mm-hmm. What would the top have to be? Ooh, I can see your brain burning. I can see you thinking.
Oh, I know.
What?
That's 1, 2, 3, 9.
Very, very good. You see how it works?
Yeah.
The relationship here is if I not multiply this by 9, I get 36. If I multiply that by 9, I just get 9.
Yeah, I'm putting down everyone like 7, 8, and 9.
Okay, excellent. Do that. So you did 1, 2, 3, 4, 5, 6, 7, 8, 9. I did it out of order, but I was doing that because you're smart, and I know that it didn't confuse you. If you weren't smart, I might just go in order. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, 10 is just going to be 10 to 40, right? And just take off the 0, right? And it'd be 11 to 44, 12, right? To 48, etc. Right?
Yeah.
But whatever it is, it's going to be 4 times the top number. Does that make sense?
Yeah.
All right, let's get a little more complicated because this is boring with the 1 on top. Are you ready?
Yeah.
All right.
I'm putting down
Okay.
9 to 34.
All right.
And 10 to 40 equals.
Okay, so get your blocks out again. See, and now when we add numbers together, this will be super easy because you'll be able to see that, oh, just make the denominator the same. Bam, we can add them, we can subtract them, we can divide them, we can do whatever we want.
Yeah.
Uh-oh, careful, careful. Yeah, you pulled the plug out of the wall. Isn't there another plug behind the computer someplace? So you're not on top of the cord? What are you doing?
I don't see any.
Okay, that's fine. Then just leave it where it is and try not to knock it off the wall again. Alright, let's get a little more complicated. What do you say?
Deal.
Alright, how about we'll do 3 to 4.
Okay.
So get out your 3
Get out my 4.
and get out your 4. Your 4 is already out, I hope.
It is.
Alright.
Now all I have to do is lift this off and get my 3.
Yeah.
There it is.
There it is.
Okay, that worked.
That's crazy that it's going to be negative 40. That's nuts. So basically you guys are just going to stay inside. Because I can tell you a story. One time I was in Chicago and I was on Congress, the one that looks toward the lake. That runs to the lake. Okay, so we're in front of a building and we turned the corner and we got onto Congress and the wind off the lake hit us. And we're Hawaii people, so I had thermal underwear on and I had boots on and I probably had 2 layers of socks on and I probably had, I know I had a jacket and a sweater and an undershirt underneath my underclothes and a leather jacket and an overcoat and a scarf. And when that wind hit me, froze to the bone like within not even a minute. Like just chilled to the bone. Even with all that layers of clothing on. Had to go sit in a tub of hot water just to chill out.
Because you're a Hawaiian people.
Yeah, I think you would have frozen too, though. And because that was one of those times when the wind chill. I don't know what the wind chill was, but it was nuts. Whatever it was.
Once the wind chill was only 15.
Only.
And then like it was like -4 that day.
Yeah. See, -4 is not too bad.
Yeah, -4D.
Oh, -4D. That's really bad. The coldest I've ever been in, I think, was negative. Geez, I think in Idaho, I've been in -50, -55, somewhere around there.
You're joking.
No, not at all. I wish I was joking.
You know
But I went outside. No, it was a blizzard, and it was like because it was windy and cold and stuff, and we were in the northern part of Idaho in the mountains, and the only reason why I went outside was just to see what it was like, and oh my gosh, that was ridiculous. I would stayed outside for like not even a minute just to see what -60 was like or -50 was like, and then for a long time it was like -10, and it got to the point where I was used to -10. And then I flew home on Christmas Day, and I came back to Maui, and I understood why the Canadians over here can walk around in shorts and t-shirts up at our crater, which is like, 30s and 40s, because when they come from -50s and 60s, that feels warm. Anyway.
Yeah. On Sunday, they set the record for -24, the coldest ever in Chicago.
Wow.
So now
and it's supposed to get even colder than that. And it's supposed to get even cold. It's going to shatter the record if it gets down to -40.
I know.
In fact, let's think about it. If it gets to -40 and the old record was 24, and it gets down to -40, how much colder is it going to be?
It's going to be about...
Not about.
-16 degrees colder.
Right? Because 16 and 24 is 40. So it's going to be 16 degrees colder than the previous record.
Yeah, and the previous record before 24 was 23.
Yeah, see? And they're trying to tell us that there is global warming. And that the global warming is causing this cooling. These people are
I'm not going to have school tomorrow, the day after Christmas.
I understand. It's going to be crazy. How often do they cancel school in Chicago? Not very often, man. It can be...
My school has never canceled school for 20 years.
Yep. So this will be the first time ever that your school is ever canceled.
First time in 20 years.
Yeah. Wow. All right. So this relationship is 3 to 4. Put your blocks correctly. He's got them stacked on top of each other. All right. And get a piece of paper or whatever. So 3 to 4 is going to be the same thing as 6 to what?
6 to 2.
Don't look at mine. Look at yours. Look at yours.
Oh.
And just grab a piece of paper or anything. You can even use one of the red blocks. There you go. Perfect. So 6 to what?
6 to 8.
Very good. And that relationship is the same thing as 3 to 4. 3/4.
Yeah.
All right, what's the next one going to be?
Red block.
Yeah. What's the next one going to be?
The next one?
Yes.
Is a red block. Nine
Yep.
and 12.
There you go. So 9 to 12 is the same thing as 3 to 4. And we just multiplied by 3, right? So you can see over here that this is 3 and this is 3. So this has got to be 9 and that's got to be 12.
Yeah.
All right, write down the next one. Keep going.
Okay, I have to write them down now.
Yes, you have to write them down now. But do you see that we're just counting 3, 6, 9, 12, and then at the bottom we're counting 4, 8, 12. What's the next one going to be?
Yeah.
Super easy, right?
Yeah, the next one is super easy.
What's it going to be?
It's gonna be 12.
2.
16.
Very good. Now see, all we're saying here is that we have 3 of these, oops, to 4 of these. And you see over here what I have is this part is the 3, this is the 4, and then this part we moved it over by 4, and this part is over by 4. So there's my 12 to 16. And if I was going to draw a picture of it, it looks like this. Oops. Let's get rid of that. And I have, this is 4, this is 4, this is 3, this is 4, this is 12, this is 16. You see my drawing?
Yeah.
And my drawing is just this. Oh, I should put a line here.
Yeah.
Right? And that's all I did is just take a piece of this, so we don't have the whole thing here. We just have 4 till there. Am I making sense?
Yeah.
Alright. So now we're going to get crazy. Oh, keep going. Do 12 to 16. And then what's the next one going to be? 5. So it'll be 15 to
20.
20. And then keep going. Write them down.
15 to 20
Yep.
equals 9 or 18
Yes. 3 6s,
to 24.
which is 4 6s. Very good. And then what?
Yeah.
7s. 3 7s is how much?
3 7s, 21.
To how many? 21 on top. And how many on the bottom?
21 on top. That must mean that 30 is on the bottom.
Oh, try again. Count it. How much is 4 7s?
Oh, wait, no, 28 is on the bottom.
Very good.
I accidentally put 26.
Okay, don't do that. You want to put 28.
28.
Yes. And then what?
And then 22.
Wait a minute. How much?
Oh, 24.
Yeah, because that's how many 8s is that?
That's gotta be 3.
Gotta be 3 8s. So what's 4 8s?
4 8?
Mhm.
And it's 32.
There you go. So it's going to be,
Oh, I get it now.
so it's going to be 24 to 32, because that's just 8s now, right?
Oh, yeah. Now I get it.
Okay. Because all we're doing, when you get down to it, is 3 4ths, and then over here, let's use a different color pen. Let's go with red.
Plus 3 plus 4
Is
plus 3 plus
8,
4
there you
plus
go,
3
is 8
plus
over
4
8, which
plus
gives me the same thing as, ooch, I'll put it down here, 24 over 32.
Oh, yes.
Does that make sense?
Yes.
That's a weak red pen, considering it's brand spanking new. And I don't know where my blue one went. It ran away. Oh no, it didn't. It's still in the container. Let's try that instead. Let's go with this instead. Oh, much better. And these are all equivalent fractions. And what's the next one going to be? Just to do 9s? What's 9 going to be?
For you?
For you.
Oh, for me, it's gonna be 27 out of 36.
27 over 36, right? So that would be, the way we would say that is 27 36. Right?
36.
And then the last one would be 30 over 40, which is just an extra 0. And then of course we could do 33 over 44. That would be the next one over. And then the last one, last one would be, what would it be? What's 12 times 3?
12 times 3 equals that plus that is that, so it's gotta be 36.
Very good. I see you do some calculating. What's 4 times 12?
4 times 12 is that plus that, which is 48.
There you go. You see how it works?
Yeah.
Easy, huh?
It slowly moves the numbers separate by 1.
Right. We just keep moving up, right? Exactly. We just keep moving up. Okay, so this is how to draw it. This is the blocks, and these are just the symbols, right? And if I wanted to get all totally nuts over here, I could put 2 more over here. And I could put 2 more 3s over here. And I would have 36 over 48. See? 12 by 12.
Oh yeah, I see.
Alright. Let's fool around with something else. Now I'm going to show you how to do something called ratios. So now let's use our imagination. And I'm going to say that we didn't have them all in a nice row. I know it's just going to be this. But I'm going to say, let's say I have 6 to 8. And then I decide that I have, instead of 12, let me get rid of all this stuff, as a matter of fact. Just be fast. Let's say I have 6 to 8, and I know that's going to be the same thing as, oh, we'll get totally crazy. I'm going to have 36 down here, but I don't know what that is. So you're going to see this on tests where it says, okay, 6 to 8 is the same thing as what to 36? Right? So here, let's draw a little picture of this. Okay, got my boxes like that. Draw this on your book, on your tablet. Same thing I just did. So we want to figure out, what does x have to be for this statement to be true? 6 is to 8 as something is to 36. Well, here's the first thing. The equal sign, does equal sign ever lie, Addie?
No.
Never lies. Alright, so that says they're the same. So this tells me that this is 6 and this is 8. This has to be 36.
Oh, what, should I put the picture on the thing?
Yeah, put it underneath, definitely. Draw it underneath, just like this. Just like how you see it here. Put this on your page. Just exactly what you see here. Put it on your page.
Oh.
Now I'm just going to tilt this down just a little.
Okay. So on that, I can't see it. 6. And then I put another one here, which I don't know.
Right. This is the box we're looking for. We're trying to figure out what's in this box. Right now, we don't know. And I'm going to show you how. And I'm going to show you an easy way to do it.
And then in this box, there's a 37.
Yeah.
I already know what the answer is.
What's the answer?
It's gotta be the 36, so 9.
Gotta be, right? Excellent. Now, that's why we like it, is because I'm showing you ones that you're going to know, and in a minute I'm going to give you ones where you don't know, because of course it's 30. Of course you got the right answer, right? It has to be 9, because, wait a minute here, is it 9?
Wait, it's 9?
It's not. It's not the X. You're right, we moved over 9 times, but hold on a second before we get crazy. What is this reduced to? Do you remember we did talking about reducing fractions?
Yeah.
So what is it reduced to?
What part reduced?
6/8. What is my reduction for 6/8? What's the lowest term for 6/8 is the same thing as what? Make it smaller.
Make that smaller?
Yeah.
3/4.
3/4. You are correct. So this is the same thing as 3/4, and this one just means that we moved over by 2, and we moved over by 2 on our blocks, right?
Oh wait,
Oh wait, get your blocks out.
I think I figured the answer.
Oh wait, oh, hold on a second. I know you figured the answer.
I figured the answer.
Alright, so what's the answer?
28.
Oh, close. So close. Try again. So Addie, how...
Oh, 27.
Aha! Why is it 27?
Because on the other page, Okay, I looked at.
Yes.
There's the 24 and the 32.
Mm-hmm.
Plus 3 is 27. And then plus 4 is 36. So it's probably.
All right. Look over here. I like it. So look over here. How far did I have to move it over to get to be 36? Down here. How far did I have to move this 4 over? I had to move it over by how much?
9 times.
9 times. So remember when I asked you, can I move the bottom over without moving the top? I cannot, can I?
Yeah.
So if I know that I moved it over by 9 here and it's 9 here, and I know that this has to be 3 and this has to be 4, right? What's 9 times 3?
Yeah. 9 times 3 is 27.
Done. So x has to be 27. Make sense?
Yeah.
Right? I'm making it pretty.
Are you gonna do something really hard that I don't know?
Oh, I'm not gonna give you really hard ones to start off. That's no fun. But I'll give you a harder one. You ready for a harder one?
Yeah.
All right. You sure?
Yeah.
Okay. So just remember, what do we have to do? First, we have to take this number and reduce it, right?
Yeah.
And then once we figure out how much we moved it over, we can figure out how much we moved this one over, and we can get our answer.
Yeah.
Because I'll tell you how they do it in school. In school, they're going to tell you to multiply 6 times 36 and 8 times x, and then take, and then it's going to be no fun, get back to 1, and you have to take 6 times 36 divided by 8, and guess what? You're going to get 27. That's a whole lot of work when you can just do 3 times 9.
Yeah, but that's much more complicated.
Of course it is. That's the way they like to teach it, is much more complicated. Let's keep it easy. What do you say?
Deal.
Okay. All right. I like it. Deal for me too. All right, buddy. Let's try. Man-child. Are you ready for a one that's going to be just slightly challenging?
Sure.
All right. How about I'm just going to change it. Instead of it being 3/4, let's make it 3/5. And I'm going to make it, I don't want to make it too easy. So let's say I have, I don't know, let's say make it 15 to 25. We'll keep it easy. 15 to 25 is the same thing as, and this time we'll know the top but not the bottom. 21, and now I don't know what that one is.
Yeah.
Alright, you gotta tell me what X is.
Oh, your answer's on your that.
Alright, so here, draw your boxes. Draw your boxes.
Drawing the white boxes.
So let's see, I know in this one it's 15. I know in this one it's 25. I don't know what's in this box, and I'm trying to figure out what's in that box. Oh, wait, I don't know what's in this box. I know that's 21, so I'm trying to figure out what's in that box. So equal sign never lies. Can you reduce 15 over 25?
Yes.
Okay, tell me what it is. What goes into both of these numbers equally?
5.
I like it. So if I do 5 and 5, how many 5s in 15?
Only 5 and 3.
There you go. How many 5s in 25?
5.
So the blocks we must be playing with are 3 and 5. See, you're a super detective.
35?
Oh, 3 and 5.
Oh.
So get out your 3 and 5 block. Look at mine. You can tell this has been in the sun. Got sun faded. Alright, so we moved over. So on this one, for sure, we moved over by...
Okay, my 3.
By that much, right?
Block. I got my 3 and 5 blocked out.
Okay. So I'm over here at 5, and I've got 15 and 25. Now, How far over do I have to move to get to 21?
From where? From where?
From here, right? Because you're here right now. Now it says 21. So 3 times what must be 21?
Let me see. Move this in.
Oh, you got yours upside down, by the way. The 3 should be on top. Yeah, there you go.
That's why I was wrong.
Yeah, you're doing it for me. All right, so move it over to 5. Now, how do I get to 21? How far over do I have to get to 21? 3 times what is 21?
1, 2, 3, 4, 5, 6, 7.
I like it. So it must be how much?
The answer must be.
Wait, before we get to the answer, I know you know the answer. But how far do I have to move over?
Let me count again.
3 times what makes 21?
3 times 1 makes 21? 7.
Well, there you go. Why are you getting all crazy with counting? So then this has to be 7 over here. What's 5 times 7?
5 times 7 equals 35.
Done. See how easy these are?
Yeah.
Right?
Yeah.
So my answer is...
I see, now I see where you got everything from.
Alright, that's the important part. So now we know that x has got to be the same thing as 35.
But what are the 7 and the 5 at the bottom doing?
The 7 and the 5 at the bottom are telling us how much we moved over. When I moved over this far, that's 5 and that's 5. When I moved over this far, that's 7 and that's 7. You see? I'm drawing a picture of this, but it's 2 different pictures.
Oh, now I know why they're there.
Alright, so draw this and put your numbers in.
I did.
You did not. Okay, well fine, then show it to me. Let's see it.
Let me just put the figure out. I'll show you both.
Yeah. Get it done, and then you can show it to me. Don't tell me you did it. Wow, I like it. Okay, now, but you didn't put all the other numbers in. You got to put this number in, and this number in, and this number in. You got to put the blue numbers in and the green numbers.
7, 5.
Yeah.
5, 7.
I like it. And you need a big old equal sign in there. Give me an equal sign. And then hold it up, and I will take a picture of that.
I'm sorry.
No, you did a good job. Alright, hold it up a little bit so I can take a picture. Alright, move it over just a little bit toward the wall. There you go. Be still. Try to hold it still. Alright, got the picture. Perfect. That's a very good job, child. That's a very good job, child. Very, very good job.
Okay, I'm gonna fix up my other page.
Alright. You're gonna fix it up, you mean?
Yeah.
Yeah, because you gotta add these extra numbers in, otherwise you don't know where the numbers came from. That's why you're being a little confused. But now you get it, right?
No. On the page, on the one that we did first.
Okay, go ahead. Take a second and write your notes. Yep, I see it. Go ahead and do it. Put them in. Put your numbers in. See, because you only had this and this and this and this, and you were missing all these other ones, and that's why it didn't make sense. But do you see that mathematicians were lazy? All these other numbers that are here are assumed, right?
Yeah.
See, because you just get the 15 and the 25 and the 21 and the x. You don't get all this other stuff. You have to do all that other stuff.
On the first equation,
Uh-huh.
It's not the same as that equation because there's not 2 digits.
I get it. Alright, so write it out. Be quick.
Wait, so I have this, so...
I understand. So you haven't put this in and this. You didn't put this in and this. You didn't put this in this. You only have these numbers inside the blocks. You got to put the numbers on the outside of the blocks.
I know, but this is the first one.
I know. Do it anyway, is what I'm saying. Put it in there. You didn't put all the numbers in. Put the numbers in.
Okay. Same thing on the board?
Yeah, no, it's a different problem, so it can't be the same thing as what's on the board. Use your brain, child.
Yeah, I know. I knew that. Well, like, I don't get what to put in.
Alright, hold it up and show me. So what do you have in there? You have 6 over 8 and 27 over 36. Six over 8 and 27 over 36. You got to put the numbers in. What are the numbers that you're going to put in? What did this reduce to? What is 6 over 8 reduced to?
3 out of 4.
Alright, then put the 3 in the 4.
Oh, I thought I had to put the same.
Oh, for Pete's sakes. How would that make any sense? So you put a 3 and a 4. So then what's going to go up here?
4.
So what's going to go on top over here? How far over do we move it to get 6?
To get 6, we moved it over 8 times.
We did not. 3 times 8 is not ever going to be 6.
24.
I'm talking about this right here. How far do we move it over to get 6?
How far do we move it over to get 6?
Yes. 3 times what is 6?
3 times what is 6? 2.
Then how far do we move it over?
Oh, 2.
There you go. Now, what number do you have over here?
Over where?
In the next box, over here.
27.
So how far do we have to move it over to get to 27?
Oh, 9.
Very good. So put the 9. Where does the 9 go?
Right there.
Right here or right there?
Oh, right.
Above the 27 or next to the 27?
Next to the 27.
So you want me to put it there? That won't make any sense either. So where should it go?
Top of the 27?
On top of the 27.
That's what I thought first.
Well, then why did you say the other? What goes over here? What goes over here?
There.
Well, what's over here, Addy?
3.
So what should go over here?
3.
There you go. Why are you trying to make this hard? You always try to make it complicated.
Oh, then, oh.
Oh.
I know the rest.
Then what does it, you know the rest. All right, there you go. Write it down. And then so if this is 4 and that's 9, what does this have to be? If I got one side of the rectangle and the other side of the rectangle, what does this have to be?
36.
There you go. There you go. There you go.
Oh,
Now here's the other thing. If I have the rectangle and I know one side, right? Oh, let's do this, like this. So I know this is 27 and I know that's 3. What does that have to be?
wait. If that's 27, then that's 3.
If that's 27 and that's 3, what does that have to be?
Oh, 9.
Gotta be 9. Can it be anything else but 9?
No.
That's why we love math. That's why we love it, because it can't be anything else. If somebody tells you it's 7 or 6 or any other number than 9, they're silly. Right?
Yeah.
Because if the whole rectangle is 27 and one side's 3, the other side has to be 9. Can't be anything but. Make sense?
Yeah.
Alright. And, oops, I'm dropping blocks all over the place. And, all we're doing, without getting too complicated about it, is drawing this rectangle. We're drawing a picture of this. And then what we're finally doing is we get to the point where we don't even draw the rectangle. We just use the symbols. Right?
Yeah.
Am I making sense to you? Yep, so take a second and draw. Do you think you could make me one, or you want me to give you another one?
You give me another one.
Okay. You want a hard one or an easy one?
Easy one.
You still want an easy one?
Just fine, hard one.
No, that's fine. I'm just asking. Well, I'll tell you what. I'll give you an easy one, and then I'll give you a hard one. How's that? Okay, deal. All right. So how about? Let's get all crazy and get rid of all these numbers. Spook. See, I need somebody to make me worksheets that look like this. And we'll get rid of this with my fingers. Trying to keep it to a minimum. Okay, so draw your boxes like this.
Ready?
Alright, so draw your 4 boxes. You gotta figure out what blocks I'm thinking about. See, you get to be a detective. Alright, so I'm gonna make this a little more complicated, but not by too much. 20 over 28 is the same thing as 35 over, I don't know. So we're looking for the box. We're looking for that box again. So your job is to tell me what x equals and to figure out all the boxes.
There.
All right. I like it. So you got your 4 boxes drawn. And you got to write the problem down. Don't forget to write this part down. Yeah, gotta write the problem down. What are we looking for? We're trying to figure out what x is. So the relationship is 20 is to 28 as 35 is to what? We want to make this sentence true, because the equal sign is never a liar. There you go.
35 is equal to what?
Yeah, 35, it's 20 over 28 is the same as 35 over what? That's the same thing as saying like 1/2 is the same thing as 2/4 is the same thing as 4/8, right? So 1/2 is the same thing as 4 over what? Same problem, right?
Wait, I'm putting everything down first.
Good, I see you doing it. But do you agree that it's the same problem?
Yeah.
Okay, so once you know how to do one, you can do any of them.
Yeah, okay, I put it down now.
Alright, so what goes in this box?
20.
Alright. What goes in this box?
28.
What goes in that box?
35.
Alright, now we gotta figure out what goes over here. Can you reduce 20 over 28? What goes into both of those numbers equally?
Let me check.
Let me check. I like it. By the way, how's your brother doing? What's he doing?
I think he's doing another math class.
Oh, excellent. It's good. Variety is the spice of life.
I can't find it.
Well, think about it for a minute. What goes into 20 and 28 equally?
What goes into 20 and 28 equally?
Yeah.
4.
I like it. How many times does 4 go into 20?
4. Or no, 5.
There you go. How many times does 4 go into 28?
5. It's gotta be 7.
There you go. Actually, I'm going to use different colors. Good job, good job. So now I know that my relationship is actually 5 to 7, right? So now I know that this is 5 to 7. So 5 times what is 35?
5 times what is 35?
Yeah.
Um,
Or 35 divided by 5 is what? So in other words, I know my whole rectangle, I know one side is 5. What does the other side have to be?
7.
Gotta be 7. Can't be anything but 7. Now, once again, can I move the bottom over? Or excuse me, can I move the top over without moving the bottom? Same answer every time. Can I move the top over without moving the bottom?
No.
I cannot. So this has to be 7 also. So what's 7 times 7?
7 times 7 is 49.
Did you get the answer? Did you get the answer?
I'm putting it down now. There, put it down.
Alright, so what's the answer? What does x have to be for this statement to be true?
49.
Has to be 49. Bam. Done. I think that's a pretty good one. I think you did a good job.
Weren't we supposed to work on percentages?
I know, but we got carried away with fractions and ratios. So we actually went on a different tangent today. We can work on percentages next week.
Okay.
And class is almost over, but we didn't start till a little bit late, so we can go a little bit longer, unless you want to quit.
Oh, we'll keep on going.
Okay. So you want to? Do you think you can give me a problem?
Maybe.
All right, try it. Let's see. You can't be wrong. So just give it a shot.
9.
Wait. I'm gonna erase everything.
I think I have an idea.
All right. What's your idea?
9.
All right, hold on. Oh, geez. It just takes me a second to erase everything. Without leaving marks all over the place and crumbs and so on. All right, so 9.
And then below the 9, put 12.
Okay, I like it.
And then on the other side,
Mm-hmm.
put 36.
Ooh, where does the 36 go? Here or here?
Bottom.
Put 36 on the bottom. All right. So I'm gonna try to figure out what that is.
Yeah.
All right, that's a good problem. So 9 is to 12 as something is to 36. Well, I can look at this and I can see what times 12 is 36?
3.
3. So what times this is, so it must be this is 3 times greater than this, so this must be 3 times greater than this. So that's one way of looking at it. So I know that this has to be 27. But let's do all the steps that I showed you because that's me skipping steps. So let's see here. I know that 9 to 12 is the same thing as 3 to 4, correct?
Yeah.
And I know that if I moved over by 9, this must be over by 3, and this must be over by 3, correct?
Yeah.
Further, I know that this is still got to be 3 to 4. You did a good job. This is a good problem. Coming from a 7-year-old. Now, if that's moved over by 4, and this is 36, and one side's 4, has to be 9. Has to be 9. Right?
Yeah.
And 9 times 3 is what?
9 times 3 is gotta be 27.
Gotta be 27.
There's no other answer.
There's no other answer it could be. You are correct. with your logic and reasoning skills. It has to be. Can't be anything else. Very good. I'd say you showed mastery there. Alright, now you want a toughie?
For sure.
Alrighty?
After the toughie, class is up.
Alright, and after the toughie, the class will be over. You're right. But like I said, we had a little technical difficulty to start, and right, because I couldn't see you and you had to restart your computer and stuff. So
That took about in about 2 minutes, class is over.
yeah, that took about 5 minutes. We started when we actually started class, it was quarter after.
Oh, well, 8:25. It was 8:15 when we started.
Yeah.
What?
Yeah. It's okay. You're my last class of the day, so I don't mind. If I had another class after you, that would be a problem. But I don't have another class, so it's okay. Alrighty then. You ready for your toughie?
Yeah. I have 7 whole minutes to figure it out.
You have 7 whole minutes to figure it out. Alrighty. How about we make this 15/36 is the same thing, and I'll make it easy by giving it the 5s, but is the same thing as, but the number's going to be a little bigger. Let's make it, let's make it 30 over, oh, that'll be too easy. Let's make it 35 over here. And I'm looking for X. I was going to make it 30, but that would be too simple. And you're smart, so I don't want to make it too easy for you. Especially if it's supposed to be the last problem of the day. I want you to think a little bit.
Okay.
Okay, you ready?
Do I have to write it down, or yes, no, you maybe something?
Yeah, definitely write it down. And see, then next week we'll do these kind of problems. We'll do some addition, subtraction problems with fractions. And we'll do some percentages. Because we didn't get the percentages today. We just played with this the whole time. Which, like I said, we got carried away. Usually you want to do some variety as the spice of life, so you don't want to just do the same thing over and over again. But because we were getting the concept down, and because it's like only your second time doing fractions with me.
Actually, it's my 4th.
We've done 4 times doing fractions?
Oh, wait, no, never mind, 3.
Okay, 3rd time doing fractions. We never do this kind of fractions, though.
Yeah, we never done this kind of fractions. We've only done impropers.
Yeah, we did we converted from improper fractions to mixed numbers, and mixed numbers to improper fractions. We did equivalent fractions. We added some small fractions together, like 1/2 and 1/3.
And then that was too easy, so.
Yeah, because you're smart and you got through it really quick. But all you gotta remember is the name of the game is to make them same before you add them or subtract them.
Okay, 15.
Alright, so what do you think? What goes into 15 and 36?
I'm first writing all the cubes down and all the numbers of the cubes.
Alright, you're writing cubes.
The squares.
What'll go into both of those numbers equally?
I'm still putting the squares.
I'll give you a hint. It's hidden in code all over the place. What's 1 and 5? 3 and 7? What's it gotta be?
What's it gotta be?
Yeah. What goes into both of those numbers equally?
5.
5 doesn't go into 36. You're close.
Oh, 5 doesn't go to 36.
In other words, what can you reduce 1536 to? Told you, this is one you gotta think.
3/4. 3/4.
3/4. I don't like it because 3/4, there's no way 3/4 is going to be the same thing as 1536.
Oh, 1536.
What number goes into both of these numbers equally? You said 5, but 5 goes in there 3 times, but 5 definitely doesn't go in there equally. You'd have like a remainder and everything. So what's another number that could go into both of those?
10, but that doesn't add up perfect.
10 doesn't work at all. Because 10 doesn't go into there equally, and 10 doesn't go into there equally. So think of another number.
Oh.
Trying to reduce 1536. Trying to reduce it. Can we get a reduction?
3.
Ooh, I like it. Does 3 go into both of those numbers?
I think.
Let's try it. How many times does 3 go into 15?
How many times does 3 go into 15?
Mm-hmm.
1, 2, 3, 4. It has to be. No other answer. Or 5.
Gotta be 5. Alright, so you say it's 3. Alright, how many times does 3 go into 36?
3 goes into the 36. 3, 6, 5, 12.
I like it. So my relationship is 5 to 12. So my relationship is 5 to 12. Oops. Transcription error. Alright, so how many 5s in 35?
How many
35 divided by 5 is what number?
It's gotta be 7.
Gotta be 7. Alright, so now you know what the two sides of this box are. 12 and 7. What's 12 times 7?
12 times 7?
Yep.
I'm writing everything down first.
I see you. I see you doing it. Good job. Good job, boy.
5, 3, 3. 3,
The suspense is killing me. Oh no, and then I lost him at the very last moment. No! He had the answer though. Wamuda Muka was going to give him a big congratulations. No! Lose him at the very last second. No! Oh, pick up the phone. I'm calling him back. I've had this happen at crucial moments with college students or high school students when we were doing algebra, and makes all the difference. But anyway, he had the answer, you know, because if he knows this is 12 and this is 7, then he just had to do the multiplication. But do you see what we're doing here? Why our kids go so well and so fast is because, look, I quit using blocks. We just drew the pictures, right? You got the 5 and the 12. We have to do all kinds of multiplication and all kinds of division to do this kind of math. We keep the numbers small and whole, and everything works out nicely. I'm going to have completion anxiety over this. Trying to get him to answer the phone. Oh well, it looks like I'm not going to get the completion, so I will complete with you guys and then call it a day. And it says they're unavailable even though I know he's sitting right there. Oh well, he probably couldn't hear it. So, we'll call it a day, and I'll just put the answer in everybody knows 7 times 12, hopefully everybody knows, is 84. So my answer is 84. Completely not intuitive, right? That's why they put them on there. Because I was going to put 30, but then it would have just been 30 and 72, and that would be too easy. Because he would have got that immediately, because he would have seen that this is double, so this is double. But if I put 35, it makes it more tricky. But there it is. All right, fooling around with fractions, decimals, relationships when it comes to numbers, and right, just playing for a little while. And notice how the child was able to give me a problem, and it wasn't a problem. He could figure it out. It was a simple problem, but for a 7-year-old to make up a problem like that, it showed that he understood what was going on. All right, Crewton Ramone's HouseOfMath.com for more.